Hello everyone, I welcome you to this video of transpose of a matrix, symmetric and skew symmetric. So let us understand what is the transpose. What do we understand by this term? Transpose of a matrix. Transpose of a matrix. Now, suppose we have a matrix of order m cross n. Then M stands for rows, N stands for columns. I interchange them, rows and columns. So that will become the transpose. Okay. So what is a transpose of a matrix? So if suppose, if A be a M cross N matrix, M cross N matrix, the matrix obtained by interchanging, okay, the matrix which is obtained by interchanging, the matrix obtained by interchanging the rows and columns, the rows and columns of A is called the transpose, is called the transpose of A. Is called the transpose of A. And how is it denoted? And is denoted by A dash or A T on top. Okay. So for in the textbook, we have taken as A dash. Clear? Now, so what will be the order? So then the order, so A's order is M cross N. So what should be the order of A dash then? A dash will be N cross M. The order, the row and the column are interchanged. That is a transpose. Now, we are going to learn what is a symmetric matrix and a skew symmetric matrix. Very, very important definition. Okay, symmetric matrix. Now, for symmetric or skew symmetric, one main important thing you should remember is a square word. Okay, so a square matrix, capital A, is said to be symmetric. Is said to be symmetric if A transpose, A dash is equal to A. Very, very important. Okay. And what is skew symmetric then? And is said to be, that means it has to be square matrix only, is said to be skew symmetric, is said to be skew symmetric if A transpose is equal to minus A. Suppose you get a 1 mark question. Let me explain to you how do you get the answers quickly. Suppose I have a symmetric matrix like this, symmetric matrix, and the question comes like this. Okay, so 1, 3, x, and 5. Find the value of x if A is a symmetric matrix. Remember, symmetric means the transpose, and this is the same. So one trick I can give you, you just see through the diagonal, the remaining numbers has to be the same in the symmetric matrix. So x is equal to 3 is your answer directly. Just to see through the diagonal. Suppose I have A is equal to 0, 3, x, and 0. And the question tells us find x if this is a skew symmetric matrix. Again, for skew symmetric, remember there are 2 conditions. Okay, so first is the diagonal elements has to be 0 only. Has to be 0. Second condition, as you go through the diagonal, the number which are remaining has to be same, but the sign should be opposite. So what is x then? X is equal to minus 3. Is that clear? So here in this type, you will get one question that is show that any square matrix can be written as sum of symmetric and skew symmetric matrix. So let us take one question. So here they will give you like this, a 3 mark question. So express 3, 5, 1, minus 1 as sum of symmetric and skew symmetric matrices. Okay, so sum of symmetric and skew symmetric matrices. Now, So any matrix, so just understand first, any matrix A, I have to write as sum of, this has to be a symmetric matrix, and here another matrix is skew symmetric. So that is when I add the two, I should get back A. Okay, so what I do is I write that as equal to P and Q, where this P is nothing but half into A plus A dash, and Q is half into A minus A dash. Just observe, when you add these two, you will get back A. Okay, so that is a trick behind this question. So let us quickly solve that answer. So the answer, first what you have to write is, so this is your matrix A. So let A is equal to 3, 5, 1, minus 1. Since you want A dash also, keep that A dash, that is transpose, ready with you. So the first row will become first column, second row will become second column, over. So now you are writing A is equal to P plus Q. So who is that P? P is nothing but half into A plus A dash. So write that half. So you have A and A dash matrices in front of you, add them. So 3 plus 3, 6, 5 plus 1, 6, 5 plus 1, 6 minus 1 minus 1 minus 2. Okay, keep it as it is. Don't divide by 2. Let it be as it is. Last step, I'm going to take out 1 by 2 common. So now I have to prove that this matrix is a symmetric matrix. What is the definition? A matrix, a square matrix is said to be symmetric if a transpose is equal to that same matrix. So let us find the transpose, P dash transpose, that is equal to 1 by 2. And first row, 6, 6 will be written first column. Second row, 6 minus 2 will be written second column. Now check, compare these two. Are they same? Yes. So I can say P dash is equal to P. So what you have proved, what type of matrix is P then? It is a symmetric matrix. So therefore, P is a symmetric matrix. This conclusion is very important. Okay. So P is a symmetric matrix. So the first case you have proved, that is the 1 mark. So that is symmetric is done. Now let us take a skew symmetric. For skew symmetric. Okay, so then we will take Q. Who is Q? Half into A minus A dash. Okay, so that is equal to half into, you have A and A dash in front of you, subtract the two. So when you subtract 3 minus 3, 0, 5 minus 1, 4, 1, here you're getting A minus A dash, no? So it is 3 minus 3, you are getting a 0. 5 minus 1, you are getting 4. 1 minus 5, you are getting minus 4. No, minus 1 plus 1, you're getting 0. Okay, so this is Q. I have to prove it is a skew symmetric. What is the skew symmetric matrix definition? When I take the transpose, it should be minus of the given matrix. So let us take Q dash. So Q dash is equal to 1 by 2 of first row, 0, 4 will be first column, second row, minus 4, 0 will be second column. Now compare the two. Numbers are the same, but the signs is opposite. So therefore, I can write this is equal to minus Q. So you got Q dash is equal to minus Q. So therefore, what is the conclusion? Q is a skew symmetric matrix. Skew symmetric matrix. So this another mark is over, second mark is over. Okay, so therefore, now what is the last step remaining? The last step remaining is you have to take P plus Q and prove back it is equal to A. So what is P here? It is half into 6, 6, 6 minus 2 plus Q is half into 0, 4 minus 4, 0. So be careful, don't take Q dash. Now you find half is common, take it out. Okay, now add the 2, 6 plus 0, 6, 10, 6 minus 4, 2 minus 2. Now divide by 2, so you are getting 3, 5, 1 minus 1. Check whether this is equal to A. So this is equal to A as desired. So you have shown any matrix, it can be any square matrix. Okay, I can write that as sum of symmetric and skew symmetric matrix as desired. So one of the important question. Instead of 2 cross 2, they can ask you a 3 cross 3 also. Same method, same steps.